Wait, why are we? So you're probably wondering, why are we watching a cheerleading video? And I'm going to tell you in a few minutes, okay? So the last few weeks, we're going to talk about what we've done for the last few weeks, okay? I'm going to take you back, and we started with constant differences. Remember, we had tables, we had constant differences, and then from there, we did constant rate of change, right? And what was another name for constant rate of change? Slope. And then from slope, we learned all about slope, we went from y-intercept. We went from y-intercept, we also learned about the x-intercept, and then we went to slope-intercept equations, okay? You were able to write an equation if I gave you a table, or if I gave you a graph. And then you were able to graph if I gave you a table or an equation, okay? So, what we're gonna do today is, okay, we're gonna apply everything that we know about slope, slope-intercept, but we're gonna apply it to a real-world problem. And it's gonna have to do with these cheerleaders. But before we go there, and I'm gonna explain the whole activity, but before we go there, I just wanna make sure that you feel comfortable with scenarios and identifying what the slope is and the y-intercept for those scenarios, okay? And then we'll explain the activity. So let's go to this. Okay, so this is just a warm-up, just to see how we're doing. Here's the situation. We open a new bank account with $50, and each month you deposit $10. What is the amount in your account as a function of time? So the question I'm asking you is, in this scenario, what is the slope in this scenario? Situation 1, what would the slope be? Jason?
10.
Okay, so the slope is 10. And Jason, what's the y-intercept in this case?
50.
50. And if I asked you to write an equation for this, what would it be, Jason?
Y equals 10x plus 50.
Good. Y equals 10x plus 50. Everyone fine with that one? Okay. Now, Jason, let me ask you one other question. If you were to graph that, can you tell me what the graph would look like if you were to graph that equation?
Well, on the y-axis, it would start with 50, and then the slope will go up by 10.
Beautiful. Very good. Okay, how about this scenario? You're draining a pool that holds 40,000 gallons of water. And every minute, 500 gallons of water are going to flow out. What is the amount of water remaining in the pool as a function of time? So again, I need to know what the slope is in this situation. What do you think the slope is? Sarah?
500.
Okay, everyone agree? 500? Vincent, what do you think?
Negative 500.
-5. Okay, do you see that, Sarah? Okay, so the slope is -500. Very good. And Vincent, what would be my y-intercept?
40,000.
40,000. And what would be my equation?
Y equals -500x
Okay, and let me ask you a question, Vincent. If I asked you to describe the graph for that, what would that be?
There's the y-axis, the first point would be on the 40,000, the line would decrease by 500.
Very good. At a constant rate. Very good. Now the third scenario. At 4 a.m., the temperature outside is -5 degrees. Every hour the temperature rises 4 degrees. What is the temperature as a function of time? Okay, Shane, okay, what would the slope be in this case?
The slope would be 4,
Very good. And what would be the y-intercept?
-5.
Very good. And what would be the equation in slope-intercept?
Y equals 4 plus -5.
Y equals 4?
-4. Wait, no, 4 plus -5.
Like that? Everyone agree? Y equals 4 plus -5. Arthur, what do you say?
You forgot to put the x.
Very good. If I don't put that x, what's going to happen with that line? What would that line be?
This can be a horizontal.
Very good. Okay, so everyone feels comfortable with these? Okay. So, now let's talk about why I showed you that video. Okay? So, instead of dealing with lines, we're going to have an activity where you're going to help these cheerleaders. Now, these cheerleaders want to go to a national competition. Okay? But there's a lot of expenses to go to a national competition. Okay, there could be airfare, there could be hotels, meals, there could also be new uniforms, okay? So, a lot of money is needed. So what the cheerleaders want to do is they want to have a fundraiser. And they're actually going to have 2 fundraisers, but we're going to start with this first fundraiser. The cheerleading team is planning to raise money by selling teddy bears for Valentine's Day. They paid $1,500 for a shipment of 300 bears, which they plan to sell for $12 each. They hope to make a profit of at least $1,000, but they know if they don't sell enough beers, they may lose money, okay? They want to explore the relationship between the number of beers they sell and their profit or loss. Okay, so there's some new vocabulary here. So I'm going to go over the vocabulary, and then I'm going to tell you what you're going to do to try to help these cheerleaders out. So what we're going to talk about first is, okay, they paid $1,500 for these 300 beers, okay, which they plan to sell for $12. They want to make a profit, so we have to understand what profit is. So profit is revenue minus cost, okay, but what does that mean, okay? So I'm going to define what revenue is. Revenue is the amount of money they're going to take in when they sell the beers. So if they sold 100 beers, let's say they only sold 100, how much money are they going to take in if they sold 100 of them? Somebody? Abby?
$0.
I'm only looking for how much are they going to take in. They're selling 100 beers at how much, Ashley?
1,200.
1,200, okay? So Abby, do you see what we're saying? We're selling 100 beers at 12, so the revenue is $1,200. You're okay with that? Everyone understands? That's what revenue, how much we're going to take in. Well, now what we have to do is we're going to figure out what profit is. But profit is the revenue, the money you take in minus the cost. So can you figure out, what was the cost? How much did they put up front? Renata?
1,500.
Okay. And so in this example, if they sold 100 beers, how much profit would they make?
Will it actually go -300?
Beautiful. It would go -300 because this is the money that I'm taking in minus the 1,500, and I get -300. Does everyone understand that? Yeah.
So they made less than they originally. They made less money than they originally used to buy the beers.
Well, what happened is, right, what happened is they paid $1,500. But if they only sell 100, they're not going to be able to cover their costs. Okay, so they have a little issue here. And that's where you're going to help them. Okay? So, what you're going to do today is you're going to be answering quite a few questions and they're in your packet. And you're going to first deal with activity 1, which is selling these teddy bears. Okay? And what you're going to do in your group is, again, answer a series of questions, but what you're also going to do is you're going to fill in this table, okay? And I didn't put headings here, so you're going to put the headings for this table. You're going to fill that in. And the other thing, besides answering the questions, you're going to graph it. Okay? And the question that you're going to try to answer for them is that they have a goal of making $1,000. Okay? And you're going to try to figure out how many teddy bears they need to sell to make that goal of $1,000. Does everyone understand what to do? Okay, so what you're going to do, don't go on to the second activity. You're only doing the first activity. I'm going to give you 15 minutes, okay, to do this. And you're going to work in your groups. I'll come around, circulate around to make sure you understand it. Okay? Okay, so go ahead. So you can look at the packets and go through that.
Okay, so we first fill out
The number of teddy bears that we sell. Yeah.
That would just be the number of
Oh, it's just the number.
So it would be the cost of higher Oh, yeah.
Yeah,
Would it be the revenue? Or the profit? It would be teddy bears. Because.
What did you say the looking at there?
This is zero. You're in debt.
Order? Purchase. Okay, the number of beers purchased. Okay. So, and what do you think the dependent variable is in this case? The amount of money they made, which another word is called profit. Very good.
So,
So left is number of bears.
would be 300. No, 150 is 300.
So the first one is so if they have sell 0 bears, they won't sell anything because they just wasted
Oh.
And then 1,000.
Oh, yeah.
No, 2,000.
So it's kind of like by 6. It goes by 6.
Profit would be 10%.
What did you say, Dan? Do they?
Every 50
Why don't you put labels on that table? Okay, put labels, and then maybe it'll be clearer to you. Okay. Okay, good. But remember, you have to look at, you might be able to see it clearer when you graph it. But remember, this is the change in Y, but you also have to look at the change in X as well. Because what's float?
It's
Or even in terms of, yeah, in terms of, okay, there's a constant difference, but you also have to take into account the number of beers that are sold at that. So if you're saying that there's this, it's going up by 600, but you also have to look at the number of beers that are sold. So you have to, because remember, think of it as rise over run, or change in Y over change in X. Okay? No, but you have to good. The other way around. Because remember, change in Y over change in X. So the other way around. And what would that equal? And you have calculators. You can use your calculators. Okay? Is it? Yeah, so look and see if you put,
Oh, I paid that.
okay, yeah. So you're saying the profit increases by 600 every 50 teddy bears. So what do you think the slope is in this?
Slope would be 600.
Would it be 600?
Or the scale is
Right, but remember, this is your change in Y, this is your change in X.
No, they got less.
So what would be the
revenue
slope? No,
than
what you have here is
expected.
good. The only question I'm asking is, what would the slope be in this case? Okay, this would be, what's the definition of slope? Okay, so what would that be? Now you're saying that it went up 600, but it went up 600 for every, beautiful. Very good. Okay?
And then we're just gonna go up by 15 for the XX.
Should we just count over?
Well, they give us room to go into the negative numbers.
So we're obviously gonna do this.
Yes.
Right at, the orange, there's the dark lines.
Are you having trouble with the scale?
You know which goes where, like, you know that the x-axis is the number of bears sold and then the y-axis is the profit.
Yes, good.
We're just trying to determine the intervals and how we can space these out.
You know, to make it easy for yourself,
The line should definitely be there.
if you use these intervals,
Just space out.
yeah, but you're probably going to make it easier for you.
Okay. Alright, 300 or 600?
Either one, either one.
Alright.
And then what would be your intervals for your x-axis?
We were thinking of just using the intervals here,
That's
so
good.
going up by
Very
500.
good. So going up by what?
Oh no, not 500.
Good. That would be good.
We're not allowed to do both. Go up by.
Oh, so we're doing everything until.
Because there's two,
Just go by 3, maybe 300.
Are you having any problems with the scale? No. Okay, good. Very good. Okay. Are you okay with the scale? How does, what to use as a scale with intervals? For the x-axis, that would be fine, and what about for the y-axis? Okay, want to do that? Mhm. Okay. Okay, so everyone at this point seems like they're graphing, which is good.
So you start with the negatives, 1,500.
Yes. Yeah. You can do it both. Yeah, very good.
Cause it like goes up by 3 and then it goes up by 2. I don't think it's awful cheap.
Yes.
It's just because when like 50 and
what will your intervals be? What are you doing as far as intervals? So you're gonna go by 600. You might want to, and what would be your, what are you gonna start here? What number are you gonna start with here? Well, where's the origin? Let's start with the origin. Okay, good. So, you could go up by 600, you could skip one, go up by 600, that's perfectly fine. Well, you can do the same thing, remember, it's, the scale's the same, going up, down, it's gotta be the same. Well, why won't it fit? Show me.
Oh, I see, you did that.
Well, are you starting here at 300, 600, 900? Zero is actually here.
Oh, yeah.
Okay.
So you fix that.
Yeah, and you should be okay. How you doing? So you did 9? Good.
It's -9.
Okay.
So you did
Now, if they sold 50, let me look at your table. At 50 was a minus 900. Okay. Okay. At 50, at 100, but you went, okay. Your scale is incorrect because here is 0. So you have 300 here. This is 0. So your scale has to be here at starting at 300. So your scale is on here. Okay? Beautiful. Beautiful. Very good. Okay. Now you're okay with the scale?
Yes.
We went 300, 600, 900, 1200, 1500.
Yes.
Okay, that's good.
So for 50, we do 50.
How did you do, Tana? Yeah. Okay, because at this point.
Oh, why?
Okay, so then you went at 300. Where's your table? Okay, so at 150. Now, 300. Okay, now look what you did. From 0 to 300. That's 300 difference. But then, here you made it 600. You don't have equal intervals here. Okay, so you have to change your scale here. Okay, to get equal intervals. Very good. Yeah.
Should we just move the numbers here down?
That's fine. You have yours fine. Okay? I go ahead and start the questions. Your graph looks good. Okay?
If we make
Shane, if you,
Oh,
and you're skipping ahead.
Okay. Now, let me ask you a question. You're saying that this is your slope?
Yes,
How did you figure that out?
because we're going over by 1.
Well, look at your scale. Over by 1 is how much? Okay. So you went over by 1 and then up by. So you're
600 over 50.
yes. Very good. Okay. Very good. Very good. Okay. Yes. Okay. Okay, how many bears will it? Now, I want you to work with your group, and I want you to figure out how you're going to go about doing it. They want to make a profit of $1,000.
$600. And if you were trying to find a middle ground between
Well, let's look at your slope. Let's look at your slope intercept equation. How did you get 600 as your slope? Okay, you went up by 600, but you forgot. How many did you go past? Over 50. Yeah, this is 1 unit. If you look at your scale, you made that 50. So it's 600 over 50. Okay. Okay. So that seems to be a common mistake. Okay. Okay. You got it right. Very good. Because I know that you've struggled with that. Very good. Okay, so go ahead.
Careful, the cheerleading team
Yeah.
sell to make their goal of at least $1,000 profit.
Do you guys want to use the graph?
The graph is easier visuals, but it all depends on
Very good. You got it. Does it make sense?
they want to make a profit.
Okay.
And by the time they have 250 bears sold, they've already made
How you doing here?
We're trying to find how many
Yes. Okay. So you're using the graph. Fine.
Yeah.
Okay, then how you doing with it?
What they
You're stuck.
No,
Okay, but by looking at the graph?
by using, by, half of, well, down.
I got 7,500.
That number is solid.
You round it down to
They sell less bears than that number.
And brought over 1,000, so I thought 225.
So what you're saying is went across
Wait, what do you?
something
Let me try to.
at 50, that runs to 100, and then okay. Is there another way you could do it? Okay, think about it. Maybe there's a better way to do it. Okay. Okay. Yes. Okay. Can you sell a part of a beer? A whole beer. So what are you gonna do? Because remember, they want to make $1,000. So how many beers did you come up with? Very good. Okay. Yes. Okay. Very good. Okay. I'm going to bring us back as a class in about 2 minutes, okay? So try the best you can, and we're going to talk about how you did with this activity. Do you know, Jonathan, what breaking even means?
Hold on, don't write that down. Breaking even.
Teddy bear.
We were looking
Yeah,
at
because I would never did it.
yeah.
Either make money or
So it would be somewhere between 100 and 100.
either make money
Oh, that's,
Yeah, it'd be
425, or 125 bears.
Okay, I think I'm going to bring you back at this point. Okay, we want to see how everyone's doing. So you filled in this table. Well, what should the headings be for this table? What did you get for the heading? Jenna?
the number of teddy bears and the profit.
So the number of teddy bears and the profit. Did everyone agree with that? And Jenna, can you tell me what numbers you filled in for the rest of this?
Negative 1,500, negative 900, 300, 900, 1,500, and 2,100.
Very good. Did everyone get that? Okay, why are there negative numbers in the second column? Why are there negative numbers, Dan?
Because they didn't make as much money as they paid for the teddy bears.
Okay, so they didn't take in enough money. Very good. Okay, then you had to graph, and a lot of problems with the graphing. A lot of problems. It was hard for you to figure out what your scale should be, your intervals. So we had a bit of a problem with this. But what was the first point you graphed? What was the very first point that you graphed? Dean?
Negative negative 1,500, 0, comma 0.
Negative 1,500 comma 0, is that what it was?
No, 0, comma negative.
0
1,500.
comma negative, what does that mean? What does that point represent? 0 comma negative 1,500.
That they haven't sold any teddy bears and they're $1,500 in debt.
Very good. And what was the last point that you graphed, Dean?
300, comma 2,100.
300 comma 2,100. Can you put meaning behind 300 comma 2,100? What does that mean?
They sold 300 teddy bears, giving them $2,100 of profit.
Beautiful. Everyone okay with that? So if you graphed it, okay, you would probably get some kind of points like this. Did everyone get something like that? I know I worked with you because a lot of you had problems with the scale. And what do you notice about the graph? What do you notice about it? Abby?
There's no line arrows at the end.
Oh, that's a mistake. Yeah, there is. Okay. So, but you said it's a line, right? So what kind of a function is this?
Linear.
Linear. And how could you have told from the table? Could you have told that this was linear?
Because it evenly goes up by 600.
Very good. The intervals went up by 600. Yes.
Why would there be arrows at the end of the line? Because they only paid for 300.
You're right. Good point. That it probably should have just ended here. So absolutely good point. So I'll just cover that up. Thank you. Yeah. Very good. Okay. So let's go on. Okay. And so some of you had problems writing the equation. Okay. You had problems with slope. But what did you end up with the equation? Renata?
Y equals 12x plus negative 1,500.
Yeah, y equals 12x plus negative 1,500. And a lot of you had 600 there, okay? Can you explain why? What happened? Why did you have 600? Sarah?
Because some people thought that because each teddy bear, like the cost of it, goes up by 600, that it would be the slope.
Okay. What didn't they take into consideration? Paolo?
The scale.
The scale of the number of beers sold, right? So when you did that, what did you end up having to do? What did you reduce it? It was 600 over 50 and you?
Reduced it to 12 over 1.
Good. Now, next question. How much profit will the cheerleading team make if they sell 275? And I'm going to also ask you did you determine this? Okay. Dan, did you want to answer? Okay. So how much profit did the cheerleading team make if they sold 275 teddy bears?
1,800.
Okay, 1,800. Everybody get that? How did you figure that out, Dan? What tool did you use to figure that 1,800? Did you use an equation? Did you use a graph? Did you use the table? How did you figure that out?
I used an equation.
You used the equation, okay. And what did you do? How did you use the equation? Where did you put this 275 in the equation? Okay, so you said you used this equation, you got 1,800. Where did you put this 275? How did you do this? Someone in his group, can someone help him out with that? Shane?
You could just do the 75 to 12 x's,
The whole 12x? It replaces the entire 12x?
not the x.
That, okay, tell me this again. Where did you put the 275?
And the x would be 275x plus negative 1,500.
So you replace the 12 with the 275.
Oh, no.
No, okay,
No,
what did you do?
It would be 12 times 275.
Right, because that x stood for what? In this scenario, what did that x stand for?
The cost there.
The,
The cost for each there.
what, did the 12 or the x
The 12.
was the cost of the beer? What did the x stand for? What did the x stand for? In this scenario, what did the x stand for? Okay, Matt.
The X stands for how many teddy bears were sold.
Very good. So the 12 stood for the cost of each beer. The X, the quantity that was sold. And what about this Y? What does the Y stand for? in this problem, what did the Y stand for? Dean?
Profit?
Profit. Very good. Okay, now this one was a tough one for you. How many bears will the cheerleading team need to sell to make their goal of at least $1,000? Okay, Maria. 209 bears. Does everyone agree with that?
Yes.
Okay, how did you figure it out? Okay, you used the equation to figure this one out. Okay, and I know she's not feeling good, so someone else in the group might have to help her out. Okay, so you used 1,000. Well, where am I going to put this 1,000 into this equation? Can someone in this group help her? Okay, Paula.
You would put it where the Y would be,
Okay, because the Y stood for what?
the profit.
Good. And you solved for this? And what did you get when you solved for it, Paula?
We got 208.3 completing,
Okay. But, can you solve? So what did you do?
so we just rounded it up.
Very good. Is everybody okay with that? Everyone understood? Very good. You did a great job with that activity. So now we're going to go on to the next activity. Okay? Now again, the cheerleader, we're helping these cheerleaders out. So we're able to tell the cheerleaders that in order to make $1,000, they have to sell 209 beers. Okay? Oh, you know what? There was one question I'm going to go back because I think there was one question I didn't answer. How many bears will the club need to sell to break even? Okay, this is an important question. My first question is, what does break even mean? What does break even? Nisha, what does break even?
It means to like not gain any money or not lose any money.
Right, good. It would cover all the costs. How many bears would they have to sell?
125.
And how did you figure that out?
We like looked at the graph and we looked at where like it hit 0.
Oh, okay, so what Nisha's group did is they went back, they looked at the graph, and they looked to see where, I don't have numbers here, but you went back and you looked to see where it would hit 0. What would be another name for that, where it hit 0? In math, what would we call that? What would we call that? Vincent? The x-intercept, very good. Okay, was there any other way that you did this? Was there any other way that you did this? Jenna?
You could have used the equation.
You could have used the equation, good. And how would you have used the equation in this instance? If you used-
You would have put the 125 in for X.
You would have put, now you're trying to figure out how many bears to break even, okay? So if you have the equation y equals 12x, okay, how are you going to use that equation to determine break even? And what were you saying, Jenna?
I said to put the 125 in for X.
But that's what you're trying to find out,
Yeah.
okay? That's what you're trying to find out. So what should you do? What should you do in this case? You're trying to figure out how to break even. Nisha?
You put 0 in for y.
You put 0 in for y because it's at the point where you make no profit. You gain nothing, you lose nothing. So you would put that in and you would solve for x. Very good, Nisha. And that's how you would get x equals 125. Did anybody do it any other way? Dan?
Well, you could use the table.
You could use the table. What did you do with the table?
Well, in between negative 300 and positive 300 is 0. And then 100 and 150 in between those is 125.
Very good. So for this problem, you could have used an equation. You could have used a graph. You could have used a table. What about the previous question? Okay. How did it work for you, the previous question, when we wanted to find out how many teddy bears? Did the graph work for you? Did the graph work for you to find out the number of teddy bears needing to be sold in order to make $1,000? How did that work for you?
The graph didn't help because it was kind of a very specific number.
Very good. Okay. And you kind of have to estimate. So sometimes one tool might work better than another tool. So very good. Very good. Now we're ready to go on and to help the cheerleaders again. Okay. Now they came up with another activity. So I'm going to have eyes on the board and then I'll let you work on the packet. Now, in this activity, okay, the cheerleading team decided to plan another fundraiser, but this time they're raffling a gift basket. And what they did is in the gift basket, they have a lot of movie items. And they decided that they're going to charge $2 a raffle ticket. Okay? So, in the basket, they have 4 movie tickets that cost $10.25 each, 12 boxes of candy, a box of popcorn, 1 box of popcorn, 4 pairs of 3D glasses. Okay, sounds like a great gift basket, right? Okay, so they're selling this, okay? And what you're going to have to do, and I'm not going to go through this because it's dealing with profit, revenue, and cost, and we just went through it. So you should know the vocabulary and the meaning. So you're going to look at that. But one thing one smart little cheerleader did was she graphed it. She actually graphed this, okay? And what I want you to do is put a title on it, and I want you to label the axes. I want you to label the y-axis, the x-axis, based on that scenario, okay? Well, another cheerleader had said, I have a different plan. Okay, so the cheerleaders were great in math, so they liked graphing. So the second cheerleader graphed the plan, but we don't have a description for the plan. Okay, so what you're going to do is you're going to look at this graph and you're going to describe what plan 2 was. Now, something could have changed, a parameter or component could have changed in the original profit function for this one. So I want you to be able to look at it and describe what's different about this one. Okay? Well, now we have cheerleader 3. Okay? And cheerleader 3 came up with a different plan. And I want you to compare this again with plan 1 and what's different about it. Okay? So you're going to look at those 3 plans. Now, each group is working at different paces. Okay? Some of you are going to finish earlier than others. If you're done, this is going to be your homework assignment, and if you're done, you can actually start it. Your homework assignment is you are going to construct a plan 4 for the cheerleaders. So what you're going to do is you're going to describe your plan 4 for the gift basket. You're going to construct a graph. You're going to write an equation in slope-intercept, and you're going to tell me what each one of those components mean. Now, if you don't get this done today, don't worry. That's going to be your homework assignment. Okay? So, does everyone understand what to do? So you're now on the second activity, and we're going to be working with raffling the basket. Okay?
Right there.
Well, we also have to find out the number of tickets sold, and then make sure the amount.
You know what I mean?
So you want to
Add all that up.
number of tickets, how much each ticket costs.
Are we calculating?
So what is the
Okay, now you're busy with the calculator. What are you doing, Vincent? Okay. Good. Good.
This is what's in the gift basket.
Oh, wait, no, 4 tickets, how much it's. Or, yeah, of that cost, then minus how much it's.
Yeah, just the revenue. The revenue piece of the profit function. Because you know what profit is, right?
Yeah.
profit is what?
Revenue minus cost.
Very good. So, how would you calculate just the revenue, the amount of money you take in?
It's how much things sold minus
Not profit, all they're asking is revenue.
how
So,
much things they sold.
very good. The amount of money that they made from the ticket. So what expression can you write to calculate revenue?
X for the tickets that they sold.
Right, right.
And then 2x.
Very good. Very good. As simple as that. Very good. So now this is leading you down.
Because they sold $2 per raffle ticket, and you don't know how many raffle tickets they actually sold. So you just substitute it for available, which is
Okay. So you're doing very well. So just continue with that. Now, are you you're at here? You actually went a step beyond what they wanted. They just wanted you to calculate revenue here, just revenue. This is what you have here is your profit.
Is it 2 times?
Yeah, that's it. That's it.
that's how much they spent in the
Yeah, they already had a table that it was wrong, it would be
Could you give me an expression for this rather than words? Can you write an expression for this? The number of tickets times the cost per ticket. So, can you write how much? And they said to let X equals one. Very good. That's it. Okay.
So if you got a table and you did the total cost for the Y, or the X and
Alright.
the X and the Y, then you would just have a constant difference.
The Y intercept would be negative.
So the constant difference would be
But
so.
what is
And
the
it's
Two X.
What is that? So, two, that they already spent $100.
Yeah.
So it's negative for every raffle. Every raffle costs just $1.
Because that's what
Yeah.
That's what we're making the raffle.
So what is the Y
Yeah.
intercept with the profit?
So, yeah, they don't sell
What is the
everything.
meaning?
There will be $100.
They haven't sold any tickets, so they spent $100.
So the Y is profit.
And the X is the number of tickets sold.
So give the graph title. What do you do?
You have to give the graph
No,
a
well, yeah,
title, label, and axis.
and then the next one is.
And the label
So the cost of
So what would you?
What is the sum of the profit function? Yeah.
Now, what are you saying is the cost of the tickets? What is it? The x-axis is the cost of the tickets? Okay, let's look at your profit function. Okay, let's look at the previous
Or,
page.
no, I don't think that the cost of the ticket would be included in
The
the graph. This is
x-intercept
the y-axis is the total.
Okay, what does, now here, you have this profit function, very good. What does that x stand for?
We're gonna have to give it a title, a label, back.
Very good.
Okay.
Okay, 2 times it would be the amount of money you take in, but that would be what? X would be, so, very good. So if you're gonna label your axis,
Okay.
okay? Very good. Very good. Very good.
Yeah, or profit. Decided to, they would like to make more profit, so they created their own thing.
I think it's
We
one
need a title.
Oh,
Oh, yeah,
yeah.
'cause that's how much they sold, right? C is 50.
Yeah.
It didn't make sense. You solved it. Oh, yeah.
Yeah, over. Okay, so.
Plan 2. The TV side they were like,
So the title be
because it doesn't, I think you have to 50. It's 25.
It can be very general. Your title can be
so
general.
it could be basketball.
You could say basket raffle, profit made.
That just means that we still take less tickets. Because the X is the number of tickets sold. But in this plan, they would sell less tickets. So X is how many tickets they sell.
Learn that, but now we have to apply that to the question. So how much does a team have to sell?
If they wanna get more profit, then
So
they
the
have
tickets
to-
cost more, but they sell less.
Right, that's right.
But they end up making more.
Yeah, I think
Oh, they put less in the basket. But that means less people bought tickets.
the team decided
Yeah, so
to
that's
make
the plastic
so
snacks.
they created
So they bought less tickets and they put less money into the cash. No, we have one of the raising the back so you just have
Yeah.
to what is depicted in this thing.
They upped the ticket.
So what do you think how would you describe this plan? Plan 2?
They put $50 into making the gift basket,
Mm-hmm.
and the number of tickets sold also
How do you know that?
because the X intercept is the number of tickets sold. And in the last one, there was 50 minutes left.
Is that what the X-intercept means? Number of tickets sold? Very good. So
No, I mean the X, the line, not the intercept.
do you know how many tickets they sold? Do you have any idea?
$50.
And what is that 25? What does that 25 mean?
So
Okay.
at 25 tickets sold, they made enough money to not make more or less.
Yeah.
Oh, okay.
Okay. But do you know how many they sold?
No.
You really don't. Is there anything on that graph that told you how many they sold? It's mostly an if. If they sold this, this is what they would make. But
Didn't they make 20? Didn't they sell $25 to break?
yes,
Or
the,
25 tickets?
right. You're absolutely right. That you can gather by that. Okay.
Well, the profit function is our
I think
Yes.
if you were looking
So parameter? What component of a slope equation, what component did the slope change? Did the x-intercept, did the line change? That's, okay.
the Y is up to negative 50, so they're only down $50.
You could just look at the graphic here. Oh, it actually looks the same. Wait, it's the same. No, it's the same. No, it's the same. It's 150, right? 50 and 25. This just divided by half, but the slope is the same. Look how it- The slope is the same.
Yes.
So nothing was changed. So where the line is, the line change.
so they
The B, the Y? Yeah, the B. But you can call it the Y-intercept. You can call it, because that's the exact name for B. So I'd rather you use that. Okay?
The team decided they would try another idea and
This time, they still spent $100, but they.
The team decided they were trying to figure out a way to create
Did you finish both?
they did the price and
They put the same.
it still goes right through to 25. But before it went through 50. So when they have
Not in these two.
I think they would have had
The y-intercept
How do you know it's different? In
Because
plan,
you don't have to do math, if you just look at it, this is.
yeah, okay.
Steep.
Okay, very good. But can you tell me what that slope is? And what that slope means in this problem? Okay. Okay, I will. I will.
the first one went like that.
Ticket price is $4.
You put $100 into the big so, but they sold 25 tickets.
And they need 25 tickets.
Were you able to do plan 3? Okay. How were you able to figure that out?
I took the slope of the slope
Okay.
and it was 200.
What parameter?
Okay. Are you working on plan 3? Okay, what happened? Remembers what component? Like what component, like of a slope intercept equation? Yeah.
It would you would have to change how much we pay and the ticket price, because that's the only.
Okay, in about 2 minutes, I'm going to bring you back as a group and we're going to discuss the raffling a gift basket. Yeah? Let me get you one. Hold on 1 second.
The original plan was $100, we spend $100, the tickets are $2. The second plan was we spend $50, $2. And the third, yeah.
What parameter changed?
Yeah, okay.
Slope and I just lost what you
Well,
Yeah.
for the, well, we're comparing this to. We need the slope. Oh, yeah. Yeah. But we're comparing this to. The number of tickets sold. It's clear that the cost per ticket has doubled. Yes.
We can start
Yeah.
the number of tickets sold against the
Yeah.
live profit again.
So what do you guys want to do?
And we can start.
We can, so it costs $8 to get tickets, so it costs $64. And then that is.
I'm gonna start at 0 right here.
Okay, I'm going to bring it back as a group and we're going to help these cheerleaders out again with this gift basket raffle. Okay, so the question was, we had to put labels on this. Can someone tell me what the equation and slope intercept form would be for this plan, for plan 1? Okay, Paolo?
Y equals 2x minus 100.
Y equals 2x minus 100. And Paolo, what does the 2 stand for?
The 2 stands for the cost per ticket.
Okay, and what about the negative 100?
That stands for how much they spent into the basket and how much they got.
Okay, very good. So if I were to put labels here, what would I put here for the y-axis? What would I put here for the x-axis? Okay, Jenna?
The y-axis would be profit and the x-axis would be number of tickets sold.
Okay, and here we would have number of tickets sold. And did you give it a title?
Yeah. We said basket raffle profit.
Okay, basket, okay, perfect. Basket, raffle, profit. Okay, and I think most of you had something like this. Okay, very good. So then what we did is we went to, okay, break even. Looking at that graph, how many tickets would have to be sold to break even? How did you determine it? Okay, Kayla.
50 tickets.
50 tickets. How did you figure that out?
We looked at where the x-intercept is,
Okay, you looked using what?
the graph.
You used the graph and you saw where the x-intercept was. Very good. And so you determined 50. Okay. What if you were going to use the equation? Did you use the equation, Shane?
Yes.
And what number did you substitute in for y?
For y, 50. Oh, wait.
Yeah, you're giving me the answer.
Oh,
What did you substitute?
Negative 100.
Okay, now let's look at this again. You had said that it's y equals 2x minus 100. We want to know how many tickets to break even. What would I substitute? How would I figure this out? To break even, what number would I substitute if I were going to use the equation? Okay, Sarah.
0.
And where would I put the 0?
And for the y.
And for the y, and then you would solve the equation. Is that what you did, Shane?
Yes.
Okay, you just didn't. Okay, that's fine. Okay, very good. Okay, you gave me the answer. Now, here's plan 2. Can someone describe for me plan 2? Can someone describe for me? Ashley.
The slope is $2 per ticket, and the y-intercept starts at -50, and they would make more money because they put less items in the gift basket, which means that they cost less more debt.
Okay, so you said the slope was, what did you say? The slope was? Okay, rather than using slope, okay. In terms of this problem, what does the 2 stand for?
It stands for $2 per ticket.
Very good. And what did you say the 50 was?
The y-intercept was -50.
And what did that stand for in this problem?
That they sold 0 tickets and they were in debt, -$50.
Okay, and -50, what does the 50 stand for in this scenario? What was the 50? Everything you said was correct. And you gave me an equation of y equals 2x, like that. What does this 50 stand for in this problem? In this raffling a gift basket, what does that 50 stand for?
The price of each basket.
Oh, okay, the cost of doing of creating that basket, yes.
It's essentially the profit, and it's negative 50 because they only put $50 into the basket.
Very good. Okay, and how did you determine the cost per ticket by looking at this graph? How did you determine it?
Oh, I found 2 points on the graph, and I did rise over run.
Okay, you found 2 points on the graph. Did anybody do it any differently? Okay, everyone did it the same way. Okay, now we got to plan 3. Okay, and what was your description for plan 3? What was your description? Donovan.
The cost per ticket is doubled from $2 to $4 per ticket.
Okay, so you said $4 per ticket, okay. And anything else? Okay, so it was $4. How did you determine that it was $4 per ticket? How did you determine that?
Well, visually in the graph, the line is much steeper than in the previous plans.
Okay, so visually, how did you get exactly 4 though? You saw that it was visually, but how did you get 4? Okay, Paula?
In plan 1, the y-intercept is the same, -100, but now instead of having the x-intercept at 50, it's at 25 because it's completely in the middle, it's half.
Okay.
So by making that line steeper, we would have to double the cost per ticket.
Okay, so that's how you did it. Matt, what did you do?
You could do rise over run, so 100 over 25, and then you get 4 over 1, which is cool.
Okay. Okay, so very good. Okay, now let's look at okay, so here we have these 2 plans, okay? And let's compare them, okay? So you told me differences. You told me, give me one difference again. What was the difference, Jenna?
Plan 2 or plan 3 is steeper.
Plan 3 is steeper, and by steeper, what would that mean in terms of this scenario?
It made more profit.
Okay, it's steeper. For a line to be steeper, what changed for it to be steeper? Yeah? The slope. And so the slope was different. Very good. Is there anything else that was different about these two? Anything else that was different? Abby?
X-intercept.
The x-intercept was different?
The y-intercept.
Okay, and what does the y-intercept stand for?
The amount of money in the basket.
The cost of the gift basket, yeah. Are there any similarities between these two? Is there any similarity? Dan?
They both break even at 25.
They both break even at 25. Very good. Which plan's better? Which plan would be better for the cheerleaders? Dean?
Probably plan 2 because it takes less tickets to break even.
Okay. Let me ask you a question. What if they only sold 10 tickets? What if no one even liked the idea of the movie raffle basket?
Mm-hmm.
Which one would be?
Does it not matter? They're both the same.
Does it matter?
Because the break-even point is.
Well, the break even, yeah, the break even, but what if they sold less than the break even? What did you say the break even point was?